Hello guys, welcome to Bugs in Code. The problem that we are going to solve today is optimal subarray. But before that, if you're new here and a person who likes stuff related to coding, then you will subscribe my channel so that you never miss out an update. So let's get started. So this is the problem statement and it says that you're given a sorted array A of length n for each I in the range of array. You have to make all elements of the array from index 0 to I equal, okay, using the minimum number of operation. In one operation, you can either increase or decrease the array element by 1. You have to return a list which contains the minimum number of operation for each I to accomplish the above task. Okay, so let me explain the problem statement with an example, and here I'm going to take an example. I'm going to take an array which is 1, 2, 3 and 4. Okay, so for this one, since this is only one element, so I need zero operation to make the element till this one equal, isn't it? After that, what I'm going to do is I'm going to move to 2. Now I'm at this 2, and in order to make all these elements equal, what I can do is I can either increase the value of 1, I can either increase the value of 1 or I can decrease the value of 2. So both this will cost same and I will have one operation. After that, I will come to this 3. Like I will come to this 3 and I have 2 here. What now I can do is I can increase this 1 to make it 2 and decrease this 3 to make it 2. So I will have total 2 operation to make all these element equal to 2. Now I come to this 4, and for this 4 I have to make all the element equal in minimum number of operations. So what I can do is I can decrease by this 4 by 1, and I can increase this 2 by 1, and I can increase this 1 by 2. So I will have total of 4 operation in order to make all the elements equal. So this is something which is going to be our output. So this is our answer. I hope you guys got the clear understanding what the problem actually says, and let me now move to the solution part. Okay, so what we have is we have an array. Let me take an array of size 7. Okay, so we have this array, and this array contains 1, 2, 3, 4, 5, 6 and 7. And what I have to do is, let's take I'm at this position and I have to make all these elements equal. Okay, so but the question that comes first to my mind is equal to what value? This is the first question that I see. After that, what I can notice here is if I take this that particular value as 1, so I will do operations like in order to make this 1 equal to 1, I need 0 operation. For this I need 1, for this I need 2, 3, 4, 5 and 6. So these are the total operation that I'm going to have if I add up all these like 6 plus 5, 11, 11 plus 4, 15, 15, 18, 20 and 21. So 21 operation I need to do. After that, if I take this particular value as 7 instead of 1, so I will do like 0 for this. I need 0 operation for this. For this I need 1, 2, 3, 4, 5, 6, and if I add up those, then I will again get 21. If I increase my value or I decrease this value, then I notice that my answer is decreasing. Like if I take 2, then I will do something like 1 plus 3 minus 2 is 1, 2, 3, 4, 5. So the value is decreased, like decreased by 6, so it will now become 15. So it is decreasing, and similarly for this the answer will come 16. So what I notice is I will have a graph something like this. So it will reach minimum point somewhere. So this minimum point, if I increase this value and if I decrease the value, then I will end up at the middle point. So I will end up at this point, isn't it? So From this, I get an intuition that I have to choose a value something in the middle in order to have the minimum operation. But the question is that middle value can be a mean as well, isn't it? So why not mean? Why not mean? Uh, I will explain you first why not mean, and then I will move to the solution part. So mean is something which totally depends on the uniformness of the array. Like if I have one, two, if I have 1, 3, 5 and 100, let's take 11. So here I have non-uniform distribution. Like here I have difference of 2, and this value is something which is exceptionally greater than all these values. So if I add up all those, I will get 120, and by 3 by 4, so I will get 30 as my mean. And if I decrease 30, then I will, for this I will get something in range 81. Like for this I will uh, close to 20, close to 24, this as well, close to 24 this. So it is something which is 80 plus 60, like 140. So, and if I take this 5 as my median, then I will get relatively less values than this, uh, close to 112. So this is something which is very smaller than this value. So that's why we are going to take median as our value, so that we can handle the cases for non-uniform array as well. Okay, so till now we have discovered one thing, that in order to have the minimum number of operations, we are going to choose median value. Like we are going to make all the value which equal to median. So if I have an array something like 1, 2, 3, 4, 5, 6, 7, then I will make all these value. If I make all these value equal to 4, then I will have the minimum number of operation. Okay, so what I can do is, now I'm going to write the first approach, which is the brute force approach. Brute force. Brute force approach says that traverse all the elements. Like I will use a loop for all elements. For all elements, I will find the answer for current element. So find answer for current index. How to find answer for current index? First find median. Like if I have 1, 2, 3, 4 till the current index, so I'm going to find the median of this. So since this is of even size, then median is 3 plus 2 by 2, like 5 by 2, and it will be 2. So now we have to make all the values equal to 2. How to make? Like I'm going to make 1 equal to 2 in one operation, 0 operation, and this will take like 2 operation, and this will take 1 operation. So total 4 operation are there. So for this the answer is going to be 4. So this is what we are going to do, and let me just now move to the coding part. So what I'm going to do is, I'm going to have a, first of all I'm going to have an answer of size n. After that I'm going to start a loop for all the elements. For the current element, I'm going to calculate my median as, median will be equal to size mod 2 double equal to 0. So if my size is even, then I will have something else, I will have something else. So for this, for even size, median is going to be a of size by 2 plus array of size by 2 minus 1, and then divided by 2. And for this the median is going to be array of size by 2. Now what I'm going to do is, I'm going to have my size as array of, like, size as I plus 1, simple. Now I'm going to start one more loop, and this loop is something which is going to traverse all the array, like for j equal to 0 and j small than equal to I and j plus plus. Then I'm going to have my value plus equal to, so this value is denoting the minimum number of operation, and I will always take the positive value. So it is going to be my array of current value minus array of median, and I'm going to have store this value in my answer. Let me initialize my value as 0. So this is what we are going to do, and let me just now return the answer. Let's check whether it works or not. So I think it should work, and let's see. Okay, so it is showing error, but I want to know why it's showing error. Let's check like what's a median every time. But before that, let me check one thing. Okay, brackets are like at right position. Okay, so I think I have to take here J, and let's check now. Here I have to check J because I am running my loop for J instead of I. Okay, so it's working now, and let me just remove this condition and submit the solution. So this is about the brute force. Obviously it's taking off n square time, so it is going to give me time limit exceed. Okay, so no doubt. And now the complexity of this is of n square. But what I'm going to do is I'm going to optimize the solution, and now it's going to be really very interesting. I want you to focus here, and from now onwards I'm going to write the optimal solution. Like, let's take an array. Okay, so remove this, and let's take an array now. I'm going to take an array which will store 1 2 3 4 5 6 7. Now I want you to see here, I'm going to make a statement which says that for each problem at ith index, the solution to this problem depends on the solution to this problem. Like, let me first write this, like answer of I depends on answer of I minus 1. Let's see how. But how? Let me explain here. If I have something like 1 2 3 4 5 6 7, then the median of this is going to be this value. Let's take it m. So I'm going to count the minimum number of operation now. Like, if I have to make this element equal to m, so I will do something like m minus 1. After that, for this I will do m minus 2. For this I will do m minus 3. No doubt for this it will become 0, so I'm not going to write it here. After that I will do 5 minus m, because now this element is greater. After that I will do 6 minus m, and I will do 7 minus m. This expression is something, so I'm going to go mathematical here. Like, this expression is something which is become 3 cross m minus, let's denote this as sum 1, and this as sum 2. So it will become 3 cross m minus sum 1. After that I will have something which is 5 plus 6 plus 7, like sum of 2 minus 3 cross m, isn't it? In this expression, what I want to do is I want to cancel these both out. Now what I get is I get something which is sum of 2 minus sum of 1. Is it? Now let me write this as, if I have an array which is 1 2 3 4 5 6 7, then the median of this array is going to be sum of 2 minus sum of 1. Similarly, this is for odd size. So this is for odd size. What about even size? If I take an array of even size like 1, 2, 3, 4, 5, 6, then I will have a median something in the middle of these two. So it will be like 3 plus 4, 7 by 7 divided by 2, so it will be 3. Now what I'm going to do, if I subtract all those, so what I will get is like, let me do it. So it will be 3.5 will be is going to be my median, and if I subtract 3.5 from all these element, like if I make all these element equal to 3.5, then I will notice that this 3.5 get cancelled out. Like if I do, let's take 3.5 in a variable x, so it is going to be 3 like x minus 1 plus x minus 2 plus x minus 3 plus similarly 4 minus x plus 5 minus x plus 6 minus x, and you can see that 3 cross x minus sum 1 plus sum 2 minus 3 cross x. So this 3 cross x will again get cancelled out. So similarly here I will get something which is sum 2 minus sum 1. Let me summarize what I have told you till now. So I'm going to like make an array which is 1 2. Okay, so it's quite light. Let me erase this. Let me write with this. So okay, so I have 1 2 3 4 5 6 7 odd size. For odd size I'm going to write sum 2 minus sum 1, but this sum 2 is this and this sum 1 is this. So sum 2 sum 1. After that, even size is 1 2 3 4 5 6 7. Let's take 8. So it will again be sum 2 minus sum 1, but now this sum 2 and sum 1 has changed. It has become like sum 2 and sum 1. Now what I want you to notice is, can we make can we derive this expression from this? Like this is I minus 1 subproblem, and let's take this as ith subproblem. So can we calculate the ith the solution to ith problem with this ith minus 1? Yes, we can do it. How we can do it, let me tell you. What I'm going to do is, I'm going to do write as answer for I is equal to answer for I minus 1, no doubt, because it is dependent. But what to do then? Then I will do something like, in this if I add 8 and if I sub okay, so here what I can notice is like what I can do here is, I have something which is equal to this. Okay, so in this subproblem, if I add 8 and okay, so I have something which is equal to this value, and what I'm going to do is, I'm going to calculate my I'm going to calculate the answer to this subproblem with the help of this I minus 1th problem. But how? This is the question. So what I can do is, in this if I add 8 and if I add this 4, so okay, so if I add this 8 and if I subtract this 4, why I'm subtracting, let me tell you. since this is sum 2 minus sum 1, so if I add this 8 to sum 2, like if I do something sum 2 plus 8, and if I add this 4 to sum 1, so it will become sum 1 plus 4, so I will get my answer, isn't it? Let me tell you again that it is sum 2, and if I add 8 to sum 2, then it will become 5 6 7 8, and if I add to this 4 to sum 1, then I will get 1 plus 2 plus 3 plus 4, but actually this sum 1 is being subtracted. So instead of changing this value, what I'm going to do, going to do this in a separate bracket. So I will do something like 8 minus 4. So, and this 4 is nothing but this 4 was the median. So what I'm going to do is I'm going to do array of current element a of I minus a of median. So this is what we are going to do. I hope you guys understood what I'm actually trying to say. So the answer to I problem is dependent on the answer to I plus 1 problem, and adding current element and subtracting the median element to that particular problem. So this is what we are actually going to do in the optimal approach. So what I can do is I can traverse the whole array, like if I have 1 2 3 4 5 6 7 8, then we can calculate our solution simply by using this formula and just uh, having an array answer. So this is what we are going to do in our optimal solution, and this is just the game of mathematics, and like what I have explained you here. So let me just now move to the solution. So what I'm going to have is, let me first remove this approach. So what I'm going to have is I'm going to have a answer array as my long, and after that I'm going to do something like I'm going to traverse the whole array, and now I'm going to do answer of I is equal to, okay, so for 0, answer of 0 will be equal to 0, no doubt. I'm going to start from 1, and my answer of I will be equal to answer of I minus 1 plus, since I have to do I minus 1, that's why I have handled the case for the 0th index already. And after that I'm going to calculate my array of I minus array of I by 2. This is what I'm going to do and answer. So let me explain you this I by 2, like I by 2 is going to my index, so I will do something which is equal to I by 2. Let's check. Why I'm not calculating the median here, instead I'm doing I by 2, I will explain you. Let me first check whether it works or not. Okay, so you can see it's working, and let me just submit it. Okay, so it's working, and okay, so it has submitted successfully, and let me explain you why I was doing I by 2 at that point instead of finding the median. So let's take a case for, this was the case where I am calculating the solution for even size subproblem with the help of odd size subproblem, but now I'm going to do something vice versa, like I'm going to calculate this solution for odd size subproblem with the even size. So like if I have an array like this 7, and I have one more array 1 2 3 1 2 3 4 5 6, so for this solution is sum 1 and sum 2, sum 2 minus sum 1 for both, but sum 2 and sum 1 something which changes, and for this my sum 2 is this and sum 1 is this. Okay, so I'm going to find the solution for this with the help of this. So I minus 1 problem is this, and I problem is this. So answer of I will be equal to answer of I minus 1 plus something, isn't it? Because it is dependent of on this problem which I have explained you. So now let me tell you how we can find the solution to this subproblem. So here notice what I'm doing. So if I add 7 to this, and if I subtract 4 from this, can you see this? Like 4 is something which is already added to this, but here 4 is something which need not to be added, and here as well 7 is something which is not added, but it need to be added here in order to get the solution to this sub problem. So I'm going to subtract this 4 and I'm going to add this 7. So again I will do something which is answer of like array of I minus array of I by 2, because this is something which is present at I by 2 index. So that's how I was doing I by 2. So I have told you the explanation for this problem and the code. So this is all about this problem. Thank you.